So, I want you to try something for me right as we start here. Just picture a box.
Like a completely empty box.
Yeah, exactly. A perfect, impenetrable box. And I want you to imagine pumping literally everything out of it.
Every single atom.
Right. Every atom of air, every stray dust mote, even every single photon of light. You just scrub it until it is absolute, pristine nothingness.
The perfect vacuum.
The perfect vacuum. Now, here's the question for you. Is that box actually empty? Or is that, that nothingness actually the densest, loudest, heaviest thing in existence?
It really sounds like a Zen code, doesn't it?
It really does.
But that specific question is, well, it's effectively the civil war currently happening in modern physics.
Right.
And if we look at the research we're exploring today, which is a really fascinating paper by Enkongluan and Nasanjargol titled Infinite Fractal Descent, the answer to your box question is definitely not empty.
No, apparently it's a machine. Welcome to the Deep Dive, by the way. I'll be your host today, navigating us through this, and I'm joined by our resident physics expert to help break it all down.
Glad to be here.
And our mission today is to really challenge the standard view of the universe, because we are looking at a theory that claims the universe isn't some probabilistic void or a cloudy quantum soup.
Far from it.
Nasanjargol is arguing that space is a dense mechanical plenum, which I guess is just a really fancy way of saying we are living inside a giant clock.
A clock made of infinite gears, just interlocking and spinning all the way down.
And when we say all the way down, we mean that literally. You know that old saying, turtles all the way down?
Right, but instead of turtles, it's spinning spheres.
Exactly. And we're going to map all of this out today. We're going to look at the architecture of the vacuum, these fractals and gears. Then we'll see how this actually solves the mystery of quantum entanglement.
That's the part that really changes everything, explaining entanglement without the magic.
Yeah, completely rewriting the rules. And then finally, we're going to talk about the space pump.
I still love that name.
It's so catchy, the space pump. Basically how this whole theory leads to a blueprint for actual superluminal, faster-than-light propulsion, a literal warp drive built on gears.
It's incredible. But before we can start building engines, we really have to understand why anyone would think the universe is a machine in the first place.
Because the standard model of physics, the one we all learned in school, it says space is empty.
Exactly. So why change that? Well, because the standard model has a hole in it, a massively glaring hole. Physicists call it the vacuum catastrophe.
Which is quite a dramatic name. Scientists don't usually throw the word catastrophe around lightly.
They really don't. So here's the situation. We have quantum field theory, or QFT.
Which is our best math for the subatomic world.
Right, our most rigorously tested theory. And QFT predicts that empty space is actually buzzing with these fluctuating fields. It gives us a mathematical prediction for exactly how much energy should be in that vacuum.
Okay, so we have a solid prediction on paper.
Yes. But then we look at the actual universe. We measure what's called the cosmological constant, which essentially tells us how much energy is actually out there accelerating the expansion of the universe.
And I'm going to go ahead and guess that those two numbers don't match.
They don't match by 120 orders of magnitude.
Wait, hold on. 120?
One followed by 120 zeros.
That's not just a rounding error. That's not like, oops, I forgot to carry the one in the equation.
No, it's staggering. To put it in perspective, that is like trying to estimate the distance to your local grocery store and missing your guess by a distance that is greater than the width of the entire observable universe.
Wow.
It is effectively the worst prediction in the history of theoretical physics.
So QFT says the vacuum should be absolutely exploding with energy. But when we actually look out there, it seems perfectly quiet.
Exactly. And this is exactly where Nasanjargol steps in with this paper, Infinite Fractal Descent, or IFD. He essentially says, look, the math isn't wrong. The energy is actually there. It's absolutely massive. We just can't feel it because of how the machine is built.
And he's going all the way back to the Victorians to explain this, isn't he?
He is. He's reviving James Clerk Maxwell.
Now, most people know Maxwell for electromagnetism.
Right, Maxwell's equations. But back in the 19th century, he had this other model, a model of molecular vortices. He imagined that space was filled with these swirling fluids, or vortices, that were interlocked by tiny idle wheels.
Idle wheels.
Yeah.
Like ball bearings between gears.
Precisely. So if one vortex spins, it turns the ball bearing, which then physically turns the next vortex. It's a direct mechanical linkage.
But Maxwell ended up dropping that mechanical part, right? Just to focus on the pure math.
He did. But Nussin-Jargal is picking it right back up. He's saying that those abstract fields we talk about today, the magnetic and electric fields, they aren't just these magical mathematical clouds. They are the bulk physical movement of these underlying gears.
So we aren't just rolling quantum dice to see probabilistic outcomes. We are watching a physical transmission turn.
A strictly causal, local, and mechanical universe.
Okay, but this is where I get a bit skeptical.
Yeah.
If the universe is literally a bag of gears, and they are all physically touching each other, wouldn't friction just grind the whole thing to a halt in, like a fraction of a millisecond? How does a machine like that run forever?
That is a very natural question. But the paper argues that at this scale, the Planck scale, and even below it, we aren't dealing with rough, microscopic surfaces.
Oh, like macroscopic objects.
Right. These structures are effectively superfluids or completely perfect superconductors. There is absolutely zero loss. The friction you're thinking of only appears when we zoom way out to our level of reality. Mass, inertia, even time itself, those are just the resistance of the gears from our macro perspective.
Okay, so let's actually look at the gears themselves, because the paper talks about this geometric architecture, and it's not just a random assortment of big and small spheres, right? There's a very specific pattern.
Yes, what he calls a decadic fractal progression.
Which just means base 10.
Exactly. The universe is completely recursive. Imagine a sphere, let's call it rank n. Inside it, or rather composing it, are smaller spheres, which are rank n minus 1. And the rule is incredibly simple. The radius of the inner gear is exactly 1/10 the radius of the outer one.
So Rn minus 1 equals 0.1 times Rn.
Yes.
But why base 10? Is the universe just naturally a big fan of the metric system?
It's actually about geometric stability. The author links this directly to E8 Lie group symmetry.
Okay, E8 symmetry.
I won't bore you with the intense multidimensional geometry of it, but E8 is basically the most efficient, mathematically stable way to pack dimensions and spheres together. Nussin-Jargal calls it a magnitude scaling tool. It resolves all that messy decimal noise into pure integer truth.
Meaning the gears lock together perfectly with absolutely no wobbling or slipping?
Precise.
Okay, so we have big gears, made of smaller gears, made of tiny gears. But here's the thing that kind of breaks my brain when I try to visualize this. If you keep going down, getting smaller and smaller by a factor of 10 every single time, what happens to the speed of these things?
This is where the physics gets wild. It's called the velocity transfer principle.
Okay.
To keep the whole machine stable, the tangential velocity, which is the physical speed at the rim of the gear, has to be preserved across all ranks.
So the edge of the tiny gear is moving at the exact same physical speed as the edge of the giant gear.
Yes.
But if a tiny wheel has to keep up with a giant wheel,
It has to spin fast.
insanely fast.
Exponentially fast. As the radius of these spheres shrinks effectively towards zero in the deeper ranks, their angular velocity, their spin rate, basically rockets toward infinity.
This is where the paper introduces that term stiffness. It says the vacuum becomes stiff due to Thomas precession. How exactly does spinning make empty space stiff?
Think of a basic gyroscope, or even just a spinning top on a table. When it's just sitting there, not moving, you can push it over with your pinky finger. It's floppy. But if you spin it up to 10,000 RPM, what happens when you try to push it?
It fights back. It wants to stay upright.
Exactly. It actively resists you. Now, imagine those vacuum gears aren't just spinning at 10,000 RPM. Imagine they are spinning at frequencies approaching the speed of light, packed infinitely tight together.
It would be hard as a rock.
Harder than diamond, harder than literally anything in the known universe. And that is exactly why the vacuum has infinite energy, but feels like empty nothingness to us.
Because it's too fast.
It's so fast and so rigid that we can't even make a dent in it. We're essentially like ghosts floating through a solid block of steel simply because we're too slow to interact with the grain of the metal.
That is terrifyingly cool.
Okay.
So the vacuum catastrophe wasn't actually a mistake at all. QFT was correctly measuring the energy of the spinning top, but cosmologists were just looking at the table it was sitting on.
That's a perfect way to put it. The energy is absolutely there. It's just locked up in this infinite rotational inertia.
So we have this incredibly stiff, spinning, mechanical universe. And if this is really true, it has to explain the weird stuff too, right? And the weirdest thing in all of physics is quantum entanglement.
Oh, absolutely.
Einstein famously called it spooky action at a distance.
Right. The idea that two particles separated by an entire galaxy can interact instantly. Einstein hated it because he wanted a local cause. He didn't believe in magic.
And IFD says, what about this?
IFD basically says, Albert, you were right all along.
But how? If the particles are literally a galaxy apart.
Because they are physically connected by the gears, the paper redefines entanglement as transspatial mechanical resonance.
Okay, let's unpack that. Transspatial mechanical resonance.
Imagine you have two fans sitting on opposite sides of a completely empty room. In a true vacuum, turning one fan does absolutely nothing to the other. Einstein was spooked because he thought the entangled particles were somehow shouting at each other across a void, like using an invisible radio.
But there is no radio signal we can detect.
Right. But Nassim Jargal says there is no void in the first place. The empty space between them is actually packed with those rank -1 spheres. So it's not a radio at all. It's a physical gear train. It's a steel rod.
Oh, I see. So if you hold a really long steel rod and push one end,
The other end moves.
instantly.
Effectively, instantly.
Yes. Right, because the connection is physical. The space itself is the mechanical transmission line.
Exactly. The forces are mediated by what's called the secondary Bjerknes force, which is a hydrodynamic force between rotating bodies in a compressible medium.
But wait, instant is a major trigger word in physics. Nothing travels faster than light. That's the ultimate speed limit.
And the author challenges that head on. He argues that Mach, the speed of light, is just the speed limit for rank-order structures.
That's your photons,
Right. Light is just a wave moving through the medium.
like sound moving through water.
Yes, exactly. But the mechanical transmission speed itself is determined by the stiffness of the medium. And remember what we just established about the vacuum.
But it's infinitely stiff.
Right. So the shock wave transmitting through the gears travels superluminally, vastly faster than the light wave rippling over the top of them. Entanglement feels instantaneous to us because those sub-rank gears are spinning at frequencies approaching infinity. The transmission line is already active and locked in.
That honestly makes spooky action sound completely mundane. It's just mechanics.
It really is, and it perfectly resolves Bell's theorem, too. We've wrestled with contextuality, where the result of a measurement seems to depend on the setup of the apparatus. Well, of course it does if the apparatus is physically, mechanically connected to the particles via a gear train. The universe is completely local and causal. The machinery is just hidden beneath our scale.
Okay, I am entirely sold on the clockwork universe. Now I want to drive it.
I knew we'd get here eventually.
Look, if the vacuum is a machine, a physical fluid of gears, can we hijack it? Can we actually build a ship that uses this?
Welcome to the magnetic vortex drive.
The space pump.
The space pump. The author treats the vacuum entirely like a fluid, a quantum ether. He even calculates the specific dynamic viscosity of it.
Really? What is it?
It's 2.2 times 10 to the -5 Pascal seconds.
Which is what, in real-world terms? Like olive oil.
Surprisingly, it's very close to the viscosity of water. And because it has fluid properties, the idea is to use the Bernoulli principle for propulsion.
Okay, the Bernoulli principle. That's how airplane wings work, right?
Yeah.
Air moves faster over the curved top of the wing, the static pressure drops, and the higher pressure underneath pushes the plane up.
Exactly. But we aren't using physical wings in space.
No.
We are using the Gertzenstein effect. This is the spark plug of the engine. It's a known principle describing how you can convert electromagnetic waves into gravitational or vacuum fluctuations. But to do it, you need incredibly strong, high-frequency magnetic fields.
So we just spin super powerful magnets.
We spin them at the exact resonance frequency of the vacuum gears. Omega field equals omega n. If you match the speed of the local subparticles perfectly, you patch the gears of the vacuum.
So wait, are we pushing off the vacuum then? Like a boat propeller churning water?
Not exactly a propeller. Think of it more like a straw or a storm front. By spinning these magnetic fields at resonance, you drastically drop the static pressure of the vacuum right in front of the ship.
You're sucking the vacuum out of the way, creating a low-pressure zone.
Yes. And the standard high pressure of the universe behind the ship shoves you forward to fill that gap.
Wow,
You don't actually move the ship. The universe moves you.
that is brilliant. But if we are tapping into the infinite energy of the vacuum to do this, shouldn't that be wildly dangerous? I mean, if I plug my kitchen toaster directly into a nuclear power plant, I don't get toast. I get a crater.
That is a very valid engineering concern. If you tap the deep vacuum directly without a filter, you'd likely destroy the local solar system.
Oh, comforting. Very comforting.
That is exactly why a huge portion of the math in this paper is intensely focused on zeta function regularization.
I saw that in the paper. The equations looked absolutely terrifying.
It's complex, But think of the zeta function like a pair of really high-end noise-canceling headphones.
Okay.
The universe is screaming with infinite energy, infinite noise. If you just let all that in, you blow out your speakers, or in this case, reality. The zeta function allows the engineers to filter out all that infinite background noise and isolate the finite value they actually need.
It essentially tames the infinity.
Right. It creates a mathematical and physical cutoff. It uses what are called Mittag-Leffler functions to suppress the deep infinite rank energy. So the engine only interacts with the specific layer of gears that gives you thrust and ignores the deeper layers that would rip the ship apart.
So we actually have a blueprint. We have the physical mechanism, we have a way to filter the fuel. But is any of this real? Or is it just really beautiful math fiction? Because writing papers is cheap, but building warp drives is expensive.
It's a fair point. But Nazenjarbal doesn't just leave it at the math. He proposes a strict proof of concept. 2 highly specific experiments we can run today.
Experiment 1. 1 being the high-frequency magnetic interferometry.
Right. The proposal is to take high-temperature supermagnets. And this is technology that actually exists right now in places like Arzamas 16 and IPMS Kyiv.
Real advanced materials labs.
Exactly. You take these magnets and you mechanically or electronically rotate the fields at gigahertz frequencies.
And what exactly are the sensors looking for when we spin them?
They place a standard test mass near the spinning magnets. If the Bernoulli pressure drop theory holds true, they should see mass fluctuations in that object. The object should physically get lighter, or its inertia should drop.
Because they've pumped the vacuum pressure away from it.
Exactly. And even a tiny drop, like a 1% reduction in inertia, would be absolute world-changing proof.
And the second experiment, the subplanckian resonance test.
This one is the real smoking gun for the whole mechanical universe. It goes right back to the quantum entanglement we discussed earlier.
Right, the instant connection.
We think entanglement is instant, but IFD says it isn't magic. It's just very, very fast mechanical transmission.
It still takes a tiny bit of time for the steel rod to push the other side.
Yes. A microscopic, almost imperceptible amount of time. In physics, we call that temporal delay hysteresis.
Hysteresis.
By observing entangled pairs with extreme subplanckian precision, they want to look for that tiny, tiny lag.
And if they find a lag?
If there's a lag, it mathematically proves the gears are there. It proves there is a finite mechanical transmission speed. It would literally be the death of the probabilistic void and the undeniable birth of the mechanical universe. We could even calculate the exact rotation speed of the rank -1 spheres based on the delay.
It really takes this impossible sci-fi idea of interstellar travel and just turns it into an engineering problem.
Yes.
I mean, a very hard problem, obviously, involving spinning supermagnets and fractal math. But at the end of the day, just engineering. Synchronization.
And it completely changes how we see the dark space between stars. We've spent a century staring at the static on a TV screen, calling it random quantum noise. This theory steps back and says, no, that isn't noise. That's the pixel grid.
Wow.
And if you understand the structure of the grid, you can change the picture.
I just keep thinking about that core image. Infinite gears. Spinning faster and faster, completely silent the deeper you go into nothingness. It's actually strangely comforting to me. There's no fundamental chaos, just a clockwork that's moving way too fast for our macro-level eyes to see.
It's a profound return to order. Determinism.
I do want to leave you with one final thought, though, as we wrap this up. If this theory holds true, if literally everything, from the deepest vacuum to the atoms in your body, is just gears perfectly turning other gears in a rigid chain of cause and effect, what does that make us?
Oh, boy.
Our thoughts, our choices, even our feeling of consciousness, just the bulk statistical behavior of these deeper, faster gears turning deterministically beneath the surface of our reality?
That is a very dangerous question to ask a physicist,
Yeah.
because we might just quantify your entire concept of free will as a high-level rounding error.
Ah, right. Just something for you to mull over next time you stare out in the empty void of the night sky. Well, thank you for joining us on this deep dive into the clockwork universe and exploring Nazenjorgel's wild mechanics with us.
It was an absolute pleasure.
Keep those gears turning, everyone. We'll catch you on the next Deep Dive.